Hi, my name is Sarah.
Hey, my name is Mitchell.
Today we'll be discussing whether things fall at the same rate and if it is the same for inclined planes. Also, we will be talking about Newton's second law and how that explains the physics behind this experiment. To begin with, we did two different experiments, one in which is free fall. In free fall, we have to focus on gravity, which is 9.8. When acceleration is at 9.8, things tend to fall at the same rate. Also, there are other factors such as air resistance that play a role in this.
And the second thing we want to talk about is the inclined fall and how the angle affects the rate of which the object falls and slides on the surface. The factors that play on this inclined fall are the slope and the friction.
With free fall and inclined fall, Newton's second law is present. Newton's second law is when acceleration is dependent on mass and net force. The equation for that is force equals mass times acceleration. Some things to know about Newton's second law is when force increases, acceleration increases, and as mass increases, inertia increases. Basically stating that forces are not balanced if Newton's law is present.
So we went ahead and did two different experiments for free fall to test the rate of which different objects would fall. So the first experiment we did was three different objects, which is a lime, a rubber ball, and a ping pong ball. They all have similar surface area, but they all have different masses. To do this experiment, we had to climb a flight of stairs to reach the constant height, which is 3.2 meters, and we went ahead and dropped each object for 5 rounds and got their average speed. So if you look at part A, the calculation says that the ping pong ball dropped at 3.628 meters per second speed, the lime with 3.712 meters per second, and finally the rubber ball with 3.857 meters per second. The graph on the right tells us the time of which these objects fell, and as you can see, it is pretty similar.
After doing the first part of this experiment, we became very curious and wanted to test this theory with three objects that had similar masses but different surface areas. And we did this by using three pieces of papers. We folded one of them in half, one of them in fourth, and then we kept one of them as whole. We dropped the three papers from a height of 1.5 meters. We used the wall as a reference for the height, and then after doing this experiment, we realized that the paper with the less surface area was the fastest. Looking at our calculations, the speed for the full page was 0.807 meters per second. For the half page, it was 1.163 meters per second. And the fourth page was 1.609 meters per second. And then looking at the graph on the right, we can see that the full paper took the longest, the half paper took less time, and then the fourth paper was the fastest.
In order to test if things fall at the same rate for inclined planes, we went ahead and tested this by using two different angled planes, one of which is 30 degrees and the other one is 45 degrees. We tested this by dropping three different objects on it with different masses and different surface areas. So the first test was dropping the book at a distance of 1.83 meters from the top of the incline. The book averaged at a 0.781 meters per second average speed at 30 degrees, and the calculator averaged at 1.236 meters per second, and the marker averaged at 1.548 meters per second.
For the second part of this experiment, we went ahead and followed the same procedure as part 2A, and we dropped all three objects from an inclined plane that was set up as 45 degrees, and the speed calculation for the book was 1.481 meters per second. For the calculator, it was 1.968 meters per second, and for the marker, it was 2.299 meters per second. Looking at the graph on the right, we can see that the book took the longest to drop, the calculator took a little bit less time, and then the marker was the fastest. Looking at the results for free fall and comparing both experiments, we can see that for part A, the speeds are very, very similar between all three objects, and for part B, that the speed is very different for all three objects. For part A, we used three objects with similar surface area, different masses, and for part B, we used three objects with different surface area, same masses. we can see that air resistance plays a big part in part B, which is the reason why the full page had the highest time, which means it took the longest to drop to the floor.
Now comparing both parts of the incline test, it shows that all objects had a slower average speed at a smaller angle, which is 30 degrees, and a faster average speed at a bigger angle at 45 degrees. This is due to the higher gravitational force acting on the object at a bigger angle, which makes it fall faster. Friction plays a role in this test with regards to each object differing in average speed as explained earlier. Thank you for reaching the end of our video. We hope that you learned a little something from our experiment and feel free to test it out for yourselves. Alright, with that being said, we'll catch you in the next one. Peace.